Solutions to differential equations are functions or families of functions. And later, when we analyze differential equations in more detail, you'll see that this differential equation represents exponential decay. And when we learn how to solve it, it has the following solution. So some constant by e to the minus x. But x will be time. So as we can see, when the constant is equal to 1, we have e to the 0, and then the solution curve follows the slope field. So you can see that we can estimate the function by following the slope field. And another example is when that constant is equal to minus 1, then according to this differential equation, minus negative values are positive. So we get positive slopes along this curve. And just following the slope field, you'll be able to sketch the solution curve. So as you can see, we have a family of solutions depending on the constant. And we'll get some practice in sketching these fields and doing some reasoning in the following example. Let's use a slope field to sketch the solution through the point 0, 2. So as we can see, the slope of the tangent to the solution curve is 0 at this point. And then if we follow the slope field, well, what we have is something like this, which follows a slope at the next x value. And if we keep following the slope field, the curve looks something like this. And on the other side, we can do the same. So you're not going to be 100% accurate, but that looks reasonable. And you can sketch another solution curve. So for example, through 0, 4, that's a bit easier to sketch. So you have a 0 slope, and then you follow the slope field as best as possible.